Welcome back to the deep dive. So, when we think about keeping data safe, our minds usually go straight to things like cooling systems, power backups, maybe a firewall.
The usual suspects.
Exactly. But today we're going to zero in on something a little different, a piece of physical security that's now, well, fully integrated into the IT world. It's the NTI E-GBS-P glass break detection sensor.
It's a very specific piece of kit.
It is. And our mission today is to figure out how a physical intrusion detector like this fits into, sophisticated environmental monitoring. Why is a physical sensor suddenly acting like a network node? Okay, so let's unpack this.
Well, what's so fascinating here is that this sensor, it doesn't really exist on its own. Its whole purpose is to be just one data point for the main NTI ENVIROMUX system.
That's the main hub, right?
That's the main hub, the thing that's already managing temperature, humidity, maybe water leaks. So when this little sensor detects a window breaking, it doesn't just, ring a bell.
Right.
It sends an instant signal to the ENVIROMUX, and that's what triggers the real alerts, email, text, whatever, straight to the IT admin's phone. It basically turns an old school alarm into a modern network notification.
So, okay, if you've got a server room with an exterior window, this is basically your first line of defense against a, smash and grab.
Exactly.
But what is it actually listening for? I mean, is it just a glorified microphone that goes off if a sound hits a certain decibel level?
No, it's much more precise than that. It uses acoustic technology that's specifically tailored to certain frequency signatures.
So not just loud noises.
Not at all. It's listening for the unique sound of glass cracking. And not just one type of glass either. We're talking plate, tempered, wired, even laminate.
Wow. Right.
And the key thing, the real differentiator, is that it uses digital signal processing, DSP.
Okay, so advanced audio filtering.
Yes, exactly. It's smart enough to tell the difference between shattered glass and, say, someone dropping a coffee mug or a cart rolling past. False alarms are a huge pain for admins.
I can imagine.
So the DSP is really what protects their sleep.
But any kind of acoustic detection has its limits, right? The spec sheet mentioned a detection range of about 25 feet, but it had a pretty big caveat. What can really kill its performance?
Sound waves can be tricky. And while 25 feet is a pretty good radius for a sensor like this, that range gets cut down significantly by soft materials.
Like drapes and blinds.
Drapes and blinds, specifically. So you can't just stick it on a wall and hope for the best. You really have to think about the room's furnishings when you're deciding where to install it.
And that kind of flexibility, it seems to extend to the installation itself. Since it needs its own power and has to plug into the ENVIROMUX, how do these things get wired up, especially in like a big facility?
Yeah.
And I think this is where it gets really interesting.
Well, if you look at the wiring options, you can see NTI was thinking about big enterprise-level deployments. You can connect it with a standard network cable, a CT5 or SANTI6, into an RJ45 port on some of the ENVIROMUX models. Or you can just use a simple two-wire setup for digital inputs on others.
And it's powered separately, which simplifies things.
Yes, it's a powered sensor, so you don't have to worry about that. But the truly standout feature here is the cable length.
The 1,000 feet, I saw that. That's over 300 meters.
It's incredible. And that tells me this system isn't just for one little server closet. It's designed for monitoring entire data center campuses or huge multi-building sites, all from one central point.
Right.
Exactly. So this single, $150 acoustic sensor is really just one tiny part of a whole ecosystem built for total operational awareness. The source material even hints at other related systems, like leak detectors and management software that can handle thousands of these sensors at once.
So the glass break sensor is just another data stream flowing into one big unified dashboard.
That's it.
So we really drilled down into this one piece of hardware, and its role seems pretty clear. It's not just about protecting the server's temperature anymore. It's about protecting the physical room itself and feeding that intel directly into the IT management stack.
We've been focusing entirely on guarding the server environment from the outside world, from physical breaches. And that kind of raises an interesting question for you, for the listener.
Okay.
Given that even a basic acoustic sensor is this integrated into the network, what level of monitoring specificity is required just to manage the internal environment? Things like vibration, airflow, hotspots within a single modern, dense server rack. I mean, think about the layers of complexity just beneath the surface.